Alright, welcome back everybody. In this video we're going to look at some examples from the improper integrals when we have infinite limits of integration lesson. There's a very important statement at the very top here. When we find these integrals, they are what are known as convergent if the associated limit exists and is a finite value, and they are divergent if the associated limit doesn't exist or is infinity, either plus or minus infinity. Alright, so let's take a look first at example 2 and how we're going to do this. Whenever we have an infinite limit of integration, we're going to replace that infinite limit of integration with some constant letter and find the limit as that constant value approaches infinity. So to do this, I'm going to take the limit as b approaches infinity, the integral from 1 to b of 1 over x dx. Okay, and then I'm going to integrate this just like I normally would. The antiderivative of 1 over x is the natural log of the absolute value of x. And we're going to evaluate this from 1 to b. So this is the limit as b goes to infinity of natural log of b minus natural log of 1. The natural log of 1 is 0, so it's completely immaterial here. And now the question becomes, what happens to the natural log of b as b approaches infinity? Well, that also approaches infinity, and so therefore this integral diverges. Okay, let's look at example 3. We're going to determine if this integral converges or diverges and find its value if it converges. So here I'm going to take the limit as a goes to negative infinity of the integral from a to 0 of 1 over the square root of 3 minus x dx. And so I take the antiderivative of this, and the antiderivative of this is going to be negative 2 square root of 3 minus x. Okay. Right. Bloody well right. Alright, and so that's going to be the limit as a goes to negative infinity of negative 2 times the square root of 3 minus negative 2 times the square root of 3 minus a. And as a goes to negative infinity, what's inside of this radical goes to infinity, and so again this one is going to diverge. Alright, and let's look at example 4. We're going to determine if this converges or diverges. Now in order to do this, since we have infinite limits of integration at both ends, what we're going to do is we're going to pick some arbitrary value between negative infinity and infinity and use that to split the integral into two pieces. Those two pieces here, I'm just going to pick 0. That seems like a reasonable place to split this. That will make my calculations fairly simple. And now when we split this into two integrals like this, in order for this to converge, we need both of those integrals to converge. And so let's see, we're going to make this the limit as a goes to negative infinity of the integral from a to 0. And if either one of these integrals diverges, then the whole thing diverges. So let's go ahead now. We'll find the antiderivative of both of these. That's the worst infinity sign ever. We'll try that again. Let's see, the antiderivative of x e to the negative x squared. We would handle that using substitution. U equals negative x squared. So du is negative 2x dx. And so dx is equal to negative x dx is equal to negative 1/2 du, and so I can replace that, and so this turns into negative 1/2 e to the u du, and so the antiderivative is going to be negative 1/2 e to the negative x squared. So negative 1/2 e to the negative x squared. And now I just want to go about the process of evaluating these limits, evaluating these integrals. So we've got the limit as a goes to negative infinity of negative 1/2 times e to the 0, negative 1/2, minus negative 1/2 e to the negative a squared. And that's going to be, again, negative 1/2 plus, oops, got ahead of myself there. It's going to be negative 1/2 e to the negative b squared minus negative 1/2 to the 0 turns into plus 1/2. Alright, now if I take both of these limits as x goes to negative infinity or positive infinity, this exponent here is going to approach negative infinity in both cases. And so those terms end up becoming 0, and we end up with just negative 1/2 plus 1/2 equals 0. So this integral converges, and in fact it converges to 0. Alright, that's the end of this particular video. We're going to come back and look at something very important in the next one. Hope to see you guys then. Have a great rest of your day.